Welcome back again to another GWT tutorial. And in this tutorial we're going to touch on a more complicated topic related to GWT. This topic is remote procedure calls, or RPC. And since this is a complicated topic, I am going to start with a presentation again, which I have for convenience opened already. So let's just start. So as I said, today we are going to talk about remote procedure calls, RPC for short, and how this is done in GWT. So what have we done in previous tutorials? Well, our focus has been on GUI building. I've shown you how to set up a basic project. I've shown all of you how to build a basic GUI, and I've shown you how to do proper GUI building, or GUI building with a proper architecture. This will become more useful again in future tutorials. But what am I going to focus on today? Well, I'm going to focus on communication between client and server using remote procedure calls. So far you've only built client-side code, GUI, so now we are going to do a server-side implementation as well. Today I will cover the basics and give a very simple example. Next tutorial I will give a more advanced example of this. And trust me, if you're a newbie in this, if you've never done this before, the simple example will be complex enough already, but as always I will do my best to explain it as properly as possible. So first I would like you to try and remember this picture. Actually, I've shown it before. So in this particular case we have the client-side GUI, which is compiled into Ajax, which is what we have focused on. This runs in the browser. And on the other hand we have a G2E servlet, which serves as our server backend, which runs on a server. I've introduced this before, and as I also mentioned before, but didn't go into further detail at that moment, the client communicates with the server using a RPC call. And in layman's terms, for people who are familiar with object-oriented programming, and I assume that as a viewer you are, a remote procedure call is essentially something like invoking a method in a class. However, the only difference is that this class is located on a server and not in the actual program or client program you're running. RPC has been around for a while. It is one of, as far as I know, is one of the precursors of web services. And with Ajax becoming more popular, like through Google Web Toolkit, RPC is basically being used to communicate towards the server. However, there is a problem with RPC, and let me try and illustrate how this works, or what this problem is, which will hopefully make it more clear as for how this RPC works. Ajax or JavaScript runs in your browser. It is code, that's being executed inside the web browser as a native program. And your web browser is single-threaded, meaning your browser can only do one computational instruction at a time. Which means if I make an RPC call from my web browser, JavaScript, to my server, the browser will actually hang until a reply is received. And if no reply is ever received, basically means that your browser will indefinitely hang, and in the end you will have to use the task manager to exit it. So to avoid a browser hanging, RPC call is made asynchronous, as opposed to the traditional synchronous pattern in which you normally invoke methods. Don't worry, I'll explain this in more detail. When making asynchronous calls, the browser does not hang while waiting for a response. So that's ideally what we need to do. Basically, we make a call for data, and my browser remains responsive until a response is received. As a matter of fact, I can even continue to do other things if it takes the server a while to respond to me with the necessary data. So, as I mentioned, what does this term asynchronous mean? Well, let me explain with a simple example. So first, the synchronous situation. The metaphor that I'm going to use for this is actually me well, icon depicting me. On the left hand side, going to call to a help desk asking a question. So traditionally it would work like this. I make the call to the help desk and I ask the question, for example, how much is 1.1? And the help desk staff immediately responds to me by saying it's 2. This would be a synchronous call. Basically, I pick up my phone, I make the call to the help desk, I ask my question, and I get an immediate response. So how does asynchronous work? Well, same scenario. Again, I am making a call to the help desk. And I'm saying to the help desk after a connection is established, how much is 1.1? When you know, call me back. And after that, I immediately terminate the connection or hang up the phone. Then the help desk staff basically goes to look into this answer that I've requested. And when he has found the answer, he will actually call me back and tell me, well, it's 2. So please note the big difference between synchronous and asynchronous. In synchronous, you get an immediate response back. As a matter of fact, you're expecting it within a matter of seconds. In case of asynchronous, it's a bit like throwing the question over the wall or throwing your request for data over the wall. And when the server is ready, it will respond to you using, well, in this case, a callback number. And this is roughly how the RPC call also works. Basically, you're throwing your request towards the server. And when the server is ready, it will basically give you a callback, which, as you will see later, actually means that some code will be executed on your side. So in today's example, what am I going to do? Well, I'm going to define RPC methods on the client side. So basically I'm going to indicate in my GUI code which RPC methods I want to utilize on the server. I'm going to implement those RPC methods on my server side. I'm going to create a dedicated class to make the RPC calls. And this is not mandatory, but it is mostly done for convenience and from a proper architecture point of view. Even though in this example it will seem a bit like an unnecessary headache. When a few tutorials later I will look into, I'll give more attention to the proper architecture again. You'll see this is actually hugely beneficial. And we're going to update our GUI based on response received from the server. So I know this sounds very complicated, so let me demonstrate it as a picture. So what our program is going to look like. Well, I'm going to have my client and my server side code again. On my client side, I'm going to have a GUI. I'm going to have this client implementation class, which is our dedicated class that makes our remote procedure calls. I'm going to define my methods, the ones that I want to have available on my server, in 2 interfaces named service and service async. You'll see them in a moment. And I'm going to implement these actual methods on my server side in the service implementation class. Then in between there, I'm going to make an RPC call. Lastly, I'm going to add a client interface, which is not mandatory. I'm only doing this to keep my code tidy. With this client interface, I'm going to enforce that all methods that I want to have in my client implementation class are implemented. As a matter of fact, I can completely leave this out of my code. It is optional, but it's a habit I developed simply to keep things a little bit more tidy. Especially because if the client implementation class gets a bit bigger, you may lose overview as for what you still need to implement and whatnot. So, with that said, let's now go into the example. I've already started up my Eclipse, and I've already created a empty project, which I have already cleaned out. So I don't have to go through the process of creating a project, cleaning out the sample code. Before I begin, I would however like to note that given that this is a very complex example where it's very easy to go wrong, I have already made an example for myself, which I'm actually having right next to my computer. So it is quite possible that this tutorial will not go as smoothly as my other tutorials, because I may every once in a while need to peek at my own example just to make sure I get all the details right. So let me take a sip of drink for a moment, because my throat is a bit dry, and let's get started. So at this moment I have nothing more than just an empty on-module load. So the first thing I'm going to do is I'm going to create two interfaces, the service and the service async interface, that are going to contain all the methods that I want to implement on my server side. And again, from a proper architectural point of view, I'm going to do this in a separate package, which I'm going to name service, and I'm going to declare it under, I'm going to create this package under my client package, because these service methods need to be defined on the client side. So having created this package, I'm now going to right click and create a new class. And I'm going to name this, well, example service. I don't need a main method. So here we have a simple class, and since this class is going to enforce what I need to... Sorry, actually I went wrong here already. It's not a class, it has to be an interface. Okay, so let's start over again. I'm going to create a interface, and I'm going to name this interface example service. And since this interface is going to enforce what I'm going to do on my server side, I'm going to extend it from remote service. And the import in this case, which it doesn't want to suggest to me, should be com.google.gwt user.client.rpc. As you can see, it's already giving me an error right now. It's telling me that the asynchronous interface is missing. So, as you could have seen in my PowerPoint presentation just now, Google Web Toolkit always basically needs two interfaces to define its methods. The service interface and the service async interface. This is mostly for tidiness, because it's only the asynchronous service that is actually being used. But, well, since Google also cares about proper architecture, you have to implement both of them. So let's just do that right now. So again, I'm going to create a new interface, and I'm going to name this, as Google suggested, example service async. It needs to be this format. It needs to be service and service async, else it won't work. And if I save now, my error has disappeared already. So it's in these two classes that at the end of it all, I'm going to define the methods that I want to see on my server side. So before I'm going to do that, I need to go back to my example service interface, and I'm going to define what Google likes to call a remote service relative path. This is essentially a shortcut name for my servlet, and I'm going to name this example service. And I need to import this as well from the RPC package. Okay, why we need this shortcut name you will see later. So that was that. Well, let's define a few methods. First thing I'm going to do is I'm going to define a method which is going to return a string called say hello, which is going to receive a string name as input parameter. And again, it's giving me an error. It's telling me that example async is missing this method, meaning example async also needs to define this. So let's just copy it. And paste it, but since asynchronous methods never return a value, because the value is coming back with the callback, as I illustrated just now. The return type is always void. Moreover, I need to provide more input parameters than just the parameter that I need to my method. I also need to provide this callback number, which is implemented as a async callback object, named callback in this case, which again I need to import. So as you can see, my errors have already disappeared, so let's do that again. Let's add another method. In this case it's going to be integer add 2 numbers. Going back to my how much is 1 plus 1 example. Integer num1 and integer num2. Enter the semicolon, and again I'm getting this error. It's saying that in async I also need to define this. So again I'm just going to copy it and add the method here. So void add 2 number. Well, let's do it tidy. Proper English, add 2 numbers. And of course I need my async callback number. And again, no more errors. So basically I've indicated that whatever my application is going to need is going to be 2 methods on my server side, namely say hello and add 2 numbers. So let me just go back to my PowerPoint presentation for a moment. I think it might be useful to visualize a bit more. So basically I just now created these 2 interfaces, which are going to enforce what has to be implemented here. So let's first wrap up the whole client-side story, and let's create this dedicated client class that I'm going to need. So going back to Eclipse, I'm simply going to create a new class now, and I'm going to name this class example service client implementation, and finish. And since I mentioned just now I want to enforce the methods here into a separate interface just for tidiness sake, I'm going to create another interface. And I'm going to name this interface example service client int. And in this client interface I am basically going to specify all the methods that my client wants to invoke, which typically should be the same methods as I've indicated in my Google specified interfaces. So let's go back to the async, copy these 2 methods, because I want to have the void methods, because typically if I invoke methods on my dedicated class I'm also not going to get a response because it's asynchronous, and thus it should be void. In this case, however, I don't need to specify a callback because it's purely my own interface. So that's that. And let's now, because I'm a lazy programmer, copy this interface name and go to my client implementation class and say, well, this client implementation class implements this interface. And it's giving me an error already, so I'm simply going to say add these unimplemented methods. Okay, so these empty methods are actually methods that will be invoked by my GUI in order to make RPC calls. So my GUI will make these method calls on client implementation, and client implementation will, through these interfaces, invoke the server. So how we're going to do that? Well, more on that probably later. Yes, let's do that later. So far I've just created a skeleton for this, enforced by that, and those two. So now let's look at the server-side implementation. So I need to create a class that actually contains my actual code. And since this is a server-side class based on a Java servlet, I can actually do in it whatever I want. I can invoke I can do calculations, use external libraries, I can invoke a database, I can do all the stuff I could regularly do in Java, which makes it very convenient. But first I need to create this class. So I'm going to say new class, and I'm going to name this example service implementation. Finish. Well, since this class exists on the server side, and thus I'm putting it in a server package, and is essentially a servlet, I need to extend this class from the remote service servlet class, which again needs to be imported from the Google RPC package. And since I want to implement certain methods here that I have defined on my client side, I must say implement example service, which is the service in my edu example client service package, or in other words, it's this particular interface. And again, I'm getting an error, so I'm simply going to say add unimplemented methods. So you will see here are actually all the methods that my client side needs, that my client side is going to invoke as a skeleton. For those who may have programmed in G2E before, you will probably remember that you need to define a servlet in your web.xml file. And this is no different. So let me just open it. So there's a nice comment here about servlets. And normally I would copy this, but in this case I will try and type it out. So I need to specify that I'm using a servlet in my program. As you may see, I always have a habit of doing the start and closing tags straight away. Mostly helps me ensuring that my XML document remains well formed. It's just my little personal habit. If you do it otherwise, also fine. So I'm going to say, well, I need to specify the servlet name using the servlet name tag. Which basically is a label that I'm going to use to label my servlet inside this document. So in this case I'm going to name it example servlet. And then I need to indicate what class is implementing this example servlet. So in this case, well, let's just do the closing tag for a moment. It would be this particular class. So let's just copy the package first. edu.example.server and then the actual class name, example service implement. So now my web.xml knows where to find it. But this servlet also needs to be invoked, and therefore we need to add a servlet mapping. And again, I need to reference this servlet name, so I'm just going to copy that. Makes it a lot easier. Not sure why my colors are thrown off, but I guess it will be fine in a moment. And then for invoking the servlet, I must use URL pattern. And for starters, I need to specify the name of the project. So in this case, that will be GWT project. Make sure I don't make a typo. 3 slash, and then the shortcut name that we defined earlier. So in this case, example service, because that's what GWT will be looking for. So save, and that should be it for the web.xml. So define where the servlet is and give it some sort of name for reference, and map the URL to that particular servlet. Again, using the same shortcut name and referring, well, provide the project name and the actual shortcut name defined in the service interface. Okay, so now let's close this, and we'll later find out whether or not I made a mistake. Let's hope not. So now I've basically set up the whole framework for this. So now we can bit by bit start implementing it. So basically I have, well, my GUI, nothing much done yet, my client implementation enforced by interface, my service interface, my service async interface, and my server implementation. So in this case, I think I'm simply going to work backwards. I'm going to start with my server implementation, because it's nice and easy. So in this case, this say hello method will basically return whatever name is provided and then add the word hello in front of it. So in this case we have a string greeting, which equals hello space plus name, and it's simply going to return this greeting. Then as for the add two numbers, what I'm simply going to do is I'm going to say integer y equals num1 plus num2, and then simply return y. And that's pretty much it for our server-side implementation. There's nothing else more to do here. Basically, when these methods are invoked, they will simply do their calculation or create their message and return it. So we are done as far as the server is concerned. So this part is done. These two interfaces were already defined and the methods were already implemented. And so let's now focus on the client implementation. This dedicated class that is going to make all these calls for us. And I better open up my example for this one, because this one is quite tricky. So the first thing I need to do here is I need to create a constructor for this example service client implementation. And this constructor is going to receive a URL as the input. And this URL is essentially the location of your servlet. Let me double check that. Yes, that is the exact location of your servlet, and how we are going to find that one I will show in a moment. And since all of these methods need to make a server invocation, a RPC call, I'm going to create an object first that can actually allow us to make those calls. And for that I'm going to create an instance of example service async, which is essentially referencing the interface defined in the same package. So to actually initialize my constructor, I'm going to say this dot, wait for my auto completion to come up, this dot service equals followed by GWT dot create example service, which is referencing to the normal service, normal interface dot class. So right now a instance is being created of a Basically, basically a stub is being created that makes our RPC calls to the server. I'm going to indicate that this is a service target endpoint. Which is going to be cast to service def target. Basically, I'm indicating that this instance I just created is a service target endpoint. As you can see, I'm not doing this part very smoothly because I am actually peeking at an example right now, because it's extremely, well, it's one of those things that you only do like once in a project and then you forget about it again, so I really don't know this on the back of my head. Finally, I'm going to say endpoint. You need to set the service entry point based on the URL provided. And then basically we have a facility available that allows us to make RPC calls. As a matter of fact, if I now invoke this say hello method, I can actually use this service object to invoke the say hello method on my client side using the name as input. And of course I need to provide a callback, which is what I'm going to do next. I need to make sure that my client can handle the response properly. But again, let me just add this here as well. Add two numbers, num1, num2, and a callback. So as I said, I need to provide a callback, and this is essentially the mechanism that will fire whenever there's a response coming back from the server. Because over here the server will be invoked and the method will just terminate, and thus also meaning that my program will just carry on, not return any results. So it's very much like the picture I showed just now. I throw my question over the wall and I just carry on with whatever I'm doing. Which also means that I need to have a mechanism, a piece of code that will trigger whenever a response is coming back. And this is what we are calling the callback. So I'm going to create a piece of code that will basically handle whatever response is coming back from the server. And I'm going to implement this as a private class default callback. Why default callback? Because I'm going to use this generic private class to basically handle every response coming back. And since it is derived from the async callback, so here it is again, I'm going to say implement the async callback interface, which I need to import, and then it's also automatically telling me you need to implement some methods for this. So let's do that. Basically, a callback class consists of a onFailure method and a onSuccess method. The onFailure method will trigger if something goes wrong on the server side and is throwing an error back. The onSuccess method will trigger if a response is coming back. So let's just do a very simple system.out over here. An error has occurred. Not occurs, it's occurred. And even though I'm going to put my code for handling this example here later, I'm simply now going to say response received. So now I have this private callback class, which doesn't do much in itself yet. I can actually use this class as the callback number when making an RPC call. So for that I'm simply going to say as the last parameter, new default callback. And since I'm a lazy programmer, I'm simply going to copy it. Okay, so if I'm invoking say hello, the RPC call will be made to the server. If I invoke the add two numbers, same thing will happen. The RPC call will be made to the server. It is indicated to the server that, well, this callback, default callback code needs to trigger if a response is coming back. So if a response is coming back, no matter which method I invoked, this onSuccess method will trigger. And this object result will actually contain the result that I've received, that is coming back from the server. So what would typically this callback do? Well, going back to this picture again, I have implemented this class which can make RPC calls to the server through this asynchronous service. Then when the server is done, response is coming back in the client implementation. The client implementation would typically have to update the GUI. But I don't have a GUI yet. So let's create one. In this case, well, I'll explain that in a moment, but let's first create a simple GUI class in a separate package GUI, and I'm simply going to call this main GUI. And I'm going to extend the composite class again, as I have elaborated on a lot in previous tutorials. So inside this main GUI, what am I going to do? First of all, I am going to create a vertical panel named vPanel. Then create a constructor to basically jumpstart my whole GUI. And using the init widget to basically load my GUI, which will start with my vPanel. I am going to create a text box in this case. Which I also need to import. So I'm going to say this.txt1 equals new text box. And I forgot the new for a moment. And I'm going to place this text box on my vertical panel. Finally, I need a button to actually trigger my remote procedure call. I'm simply going to name this one BTN1. And since this is going to invoke the say hello method, I'm simply going to assign the text to it, say hello. And I'm going to attach this to the vertical panel as well. Then this button will need to do something. So let's create a click handler for it. BTN1 click handler. And implement the unimplemented method. So typically when I press this button, I will have to make an RPC call. But I can't do that yet because I cannot at this point invoke my client implementation class. I could, of course, over here, create an instance of my client implementation class and start invoking it. However, this would mean that in every single screen I need to create an instance of this. And I want to minimize my memory load a little bit. So preferably I want to have one single instance that basically will take care of everything. So I'm going to do that in a moment. Which brings me also with a bit of a chicken and an egg problem. Which one has to come first? Does the client implementation class need to exist first? This class or this class? So far, we have always created the GUI first and then everything else. However, as I will demonstrate to you in a moment, I'm going to, in this case, implement this first. I will explain in a moment why. Let me first wrap up this particular screen. I need a label to display my result, which I'm also going to declare globally. Because I need a means to display whatever response I'm getting back from the server. And I'm simply going to make this result will be here. And I need to attach this button click handler to my button. So btn1 dot add click handler is new btn1 click handler. Okay, so how am I gonna glue these two things together? Well, interestingly, GUI needs an instance of client implementation to make RPC calls. However, client implementation needs to update the GUI and thus also needs an instance of GUI. But I don't want to have two instances of the GUI running around, and preferably I also want to have only one instance of client implementation. So how am I going to solve this? Well, the client implementation is going to create an instance of the GUI and not the other way around. So in this case, I'm going to store an instance of my GUI globally. And I'm going to initialize this. Let's first handle the import, edu example client GUI. And I'm going to initialize this particular GUI in my constructor. And since at this point the client implementation class instance already exists, I can simply pass an instance of this class himself to my main GUI by using the keyword this. Right now I'm still getting an error. That's because this particular parameter is not added to the constructor yet. So what I'm simply going to do is I'm going to add a parameter to the main GUI constructor. And I'm going to name it service implementation. And I'm also going to store this globally. And I do that by saying this dot service implementation equals service implementation. So the client implementation creates an instance of main GUI, passes a copy of himself to the main GUI. The main GUI receives this copy here and stores himself globally. And that's very convenient, because now when I click my button, I can simply say service implementation. Can you say hello for me? As a matter of fact, I can even say string name is whatever is in the text box, and this name can be passed on to my service call. So right now I have a button on my GUI and a text field, and the content of the text field is going to be sent to the client implementation, is going to be sent to the server side through a RPC call. A response is going to come back to the client implementation again. Then the client implementation needs to update the GUI. As a matter of fact, it needs to update this particular label. However, right now I don't have a facility yet to do that. So I'm simply going to create a simple public method here. See, for some reason I'm getting an email right now, so sorry about that. Public void update label. String greeting. And this greeting is going to be attached to this result label using setText and setting the greeting to it. So now I can update. There is a method there that the client implementation can use to update the result on screen. So going to the default callback. First I need to check what data type is coming in. And I will elaborate more on data types in my next tutorial. For now, let's just say that I'm going to do a very simple check on whether or not this object result, because it could be either a number or a string, it could be either the result of a calculation from add to numbers or to say hello. I'm going to check whether or not it's a string or a integer. So how am I going to do that? I'm going to say if result, which is this object, is a instance of string. What I'm going to do is I'm going to invoke on my main GUI the update label method, and I have to put the result in there, which needs to be a string. For that I need to cast it first, so string greeting equals a cast from result to string, following which I provide this greeting to my update label. So now we have become full circle. I can go from my GUI to my client implementation to my server, from my server back to my client implementation, and update the GUI. However, I still need to jumpstart this whole thing. If I look at my GWT project 3 on module load, there is nothing happening yet. So basically I need to create an instance of client implementation here, which will then in turn create an instance of the GUI. So let's do that first. And again, I better open up my example for this one. So in this case, I'm going to create an instance of example service client implementation. And I'm going to name it client implement is new. And let me just enlarge this because this is going to be a long line. Example service client implementation GWT.getModule base URL, which basically is the URL of my web application when deployed, plus the shortcut name again. So basically, as you may remember, in my client implementation I want to know the URL of my servlet, so I can set it as my target endpoint. So thus I'm providing it over here in this format. Of course I need to import. I'm using this so basically I can deploy this GWT get module base URL, so I can deploy my application under any name on any server, and my client will always be able to find the correct URL of the server path. Maybe I'll show that later. Well, actually I can just ensure of it right now. What I'm going to do is I'm going to do a system.out.println line and print this URL. So later you will see the full path of my application. Then this client implementation doesn't contain any GUI onto itself. And yet my root panel, as you may remember, needs to have some sort of GUI class to attach to itself, to the HTML page. So this should be attached to it. So how are we going to solve that? Well, in my client implementation, I'm simply going to create, I think I'll do it over here, another public method, which will basically return an instance of the main GUI. So that my root panel can basically say client implementation, can you get my main GUI, can you give me your main GUI so I can attach it to my HTML page, and then we're completely full circle. As a matter of fact, I think right now we can run this project. Hopefully nothing goes wrong because we've done so many things. It is quite likely that I made a mistake somewhere. Anyway, we'll deal with it as and when it comes up. So let's for now wait for the URL to come up, and there it is. Open my Chrome browser. And when recording, everything is horrendously slow. So let's not wait for my internet to come up and just straight away load the project. So by right in a moment you should see that very basic GUI come up. There's the servlet path. So basically it's my local host, port 8080, where the debug mode is running on, the name of my project, and the example service. So far so good. So let's give this a try. Let's say hello, well, John Smith. I say hello. If I press this button by right, and let's hope it works out well, my GUI should invoke the client implementation, which makes the call through the service async to the server. Server adds hello in front of it, sends it back to the client implementation, which updates the GUI. So let's see what happens. So far totally nothing. So let's see if there's an error. I think I already know what I've... No, that's not what I've done wrong. Oh wait, I forgot to add my label to my vertical panel. Naturally, nothing will display then. And I should have noticed that just now. Anyway, no harm done. Let's just reload. So again, let's say John Smith. Say hello, and it says hello John Smith. So we've just gone full circle. We've had our client invoke our client implementation, which made the RPC call for us. The server handled the request, sent us a reply, the callback, and the callback decided to handle to update the label on the GUI. As a matter of fact, just to make this more clear, I think I can use some breakpoints to illustrate this. So first, starting in the main GUI, I'm gonna add a breakpoint here. Then I'm gonna add another breakpoint inside my client implementation. And I'm gonna put 2 breakpoints there. Inside the on success as well. And while I'm at it, I might as well add another breakpoint here. And on my actual server side. So now let's run this thing in debug mode. So you can see step by step what is happening. And again, I'm still sipping my drink because my throat is still rather dry. So I think John Smith is a bit boring, so let's say hello Peter this time. So I click, then my Eclipse should go into debug mode. So I'm in my on click. The name gets read from the text box. The service implementation, the client implementation class will be triggered. So now we are in a client implementation class, which is going to make our RPC call. And now my plugin is telling me, do you want to continue? Would you like to stop it? No. So now by right we should end up on my server side. Yes, we are on the server side class now, in which this name Peter is received. My greeting is composed and returned. which then ends up in the default callback, which is nicely cast, hello Peter, then sent to the update label method on the main GUI. Then inside the main GUI, the update label method is invoked, which basically puts this hello Peter message on the label. And then this is the end result. So that's that. Okay, let's now demonstrate this using the add number example. And I'm going to do this one a bit faster. So I'm going to say, well, I'm going to create another 2 text boxes. And I'm going to initialize them here. txt num1 equals new text box. There you go. Then I'm going to add these 2 to my vertical panel. And naturally, I need a button to invoke this. So again, button btn2 in this case equals new button. Add 2 numbers. And this button will also be added to my vertical panel. And finally, I need a sum label, which also needs to be declared globally because I'm gonna have to update it again externally. So private label sum LBL, this dot sum LBL equals new label. Sum will be here. And what I forgot just now, and won't forget this time, is I need to add my sum label to my vertical panel as well. Finally, I need a click handler to jumpstart this whole thing. Since I'm, again, always the lazy programmer, I'm just going to copy this one. So it's going to be btn2 click handler. And I'm going to remove this for a moment. Let's first attach the click handler. btn2.add click handler equals new btn2 click handler. So what am I going to do here? Well, first of all, I need 2 integers from my text box. So I guess I'm going to say integer num1 equals, let's do a cast integer value of, and the name of my text box was txt num1 dot get text, integer num2, same thing but then different text box. And now I have those 2 numbers, I can just make my RPC call again using my service implementation. Add 2 numbers, num1, num2, done. So basically the same mechanism will be used again. The client implementation will handle this particular call, will invoke the server side. The server side will add those 2 numbers, return the result, and then the default callback will be triggered again. In this case, the result coming back is not a string, but an integer. So I need to check for that properly. So instead of saying if result is instance of, I'm going to say else if result is an instance of integer. And if that is the case, well, I need to cast, of course. Not sure if I'm doing this exactly right. Yes, it doesn't seem to be a problem. Main GUI dot, well, I need to update the sum label, and for that I hadn't created a method yet. So again, instead of doing this, update sum label, and not a string as input but a integer sum. And the set text is going to be not on result label but on sum label dot set text, double quotes because it respects a string, followed by sum. And that should be, well, other aside than invoking this, update sum label, and that should be it already. So now let's run this project again. So yeah, I have my two text boxes here that add two numbers. So in this case, I'm going to say 35 and 7. Press add two numbers. And the result is the answer to life, the universe, and everything else, namely 42. So yeah, there we go again. Our GUI invokes a client implementation, invokes the server side, sends back a response, updates the GUI. So that was our second RPC call. So basically I know I've gone through quite a fair bit of setup, but once the setup is very easy. As a matter of fact, if I need to add another RPC method to it, what I typically do is I go back to my service implementation, string say goodnight, which receives another string as input. I add the very same method to my async class. And of course need to indicate that since this is an async method, a callback needs to be defined. So that part is satisfied. Then update my client implementation interface by adding the same method, which will then indirectly force me to implement this method in my client implementation class. And that's why you can see it's very useful to have a separate interface for this. So let me just move this up a little bit just to keep it more organized. Then inside this client implementation class, I can straight away say this.service.say goodnight. And again, I'm going to use my default callback and save, so that part is done. Then finally, I need to implement this on my server side, which is already forcing me. So say goodnight in this case is going to be same thing as hello, except for the message goodnight. Save, done. So basically just now I've added a whole RPC call and implemented it. So just for the sake of this example, because I want to make it a quick example, I am going to use the same detection if result is instance of string and update the same label. The only thing that I'm going to do differently is the invocation, of course. So going back to my main GUI, instead of saying say hello, I am now going to invoke say goodnight. So now let's run this. Let me just in case do a full restart. So again, let's just say John Smith again. So say hello, say now, well, good night John Smith. So it's as simple as that. One question you might be wondering at this moment, so what if I have two RPC methods, like I had just now, that both return a string? How can I distinguish what string should update what GUI component? Well, that's a very good question, and I'll be answering this elaborately in my next tutorial. In short, typically you don't return primitive types. You return objects, so you can make more of a distinction between the result that's coming back. However, for the simplicity of this example, I decided to use primitive types instead. And that will straight away also be the topic for my next tutorial. In my next tutorial, I'll be elaborating on this example by returning objects as data structures, which makes it, and we're probably going to elaborate the GUI a bit more as well. So more on that next time, and for now I guess I could say, in line with my example, good night.